This video is about negative and zero exponents. Let's start by looking back at some of what we learned last time. If I have x to the fifth over x to the second, we agreed that that meant that I could take x to the fifth minus 2 and get x to the third. The reason we said that was true is because I have x to the fifth over x to the second. These cancel out, and I'm left with, on the top of my fraction, x to the third. Now, what happens if I end up with a problem like this? X to the third over x to the second. If I make my change here and I get x to the third minus the second, I would get x to the first. Well, remember, anything to the power of 1 is itself. So if I have 10 to the power of 1, or 110, I have 10. So in this situation, I can leave it as x to the first or write it as x. But what happens if I have something like this? X to the 2 and x to the second power. So now I have x to the second power over x to the second power. Let's say this was 3 to the second power over 3 to the second power. If I calculate that, that's 9 over 9. Or 9 over 9 we know is 1. So, if I have x to the second power over x to the second power, that's like x to the second power minus 2, which equals x to the 0 power, which is 1. Just like we had here. Now let's go one step farther. What if I have x to the first power over x to the second power? Now my math problem looks like this. X to the first power minus 2, and I end up with a negative number, x to the negative 1. Right? Well, this is the same as writing x to the first power. When you see a negative exponent, this is how you could write it without the exponent. So, let's think about that, why that's true. If I have x to the first power and x to the second power on the bottom, these two can cancel out. I'm left with x on the bottom. These became 1, so I have a 1 on the top, and I'm left with 1 over x. So that's why this becomes this. Let's look at another example. What if I have x to the negative 1 power over x to the second power? If I were to write this out as a math problem, I would get x to the negative 1 minus 2. Right, if I were to DPS this like you should, you would get x to the negative 3 or 1 over x to the third power. Notice how my power becomes positive and my variable goes to the bottom. Another way to look at this problem is this here, like we saw up here, is really 1 over x, and then we have 1 over x to the 2, which is really 1 over x to the 3. So either way we look at this, we're going to get the same solution. Now let's look at this in the terms of rules or laws of exponents. The first one that I'm going to talk about is what we call the DZP. You should be able to find this in your purple packet, and it's called the definition of 0 power. dzp. And the definition of zero power is where all real numbers x, where I have x to the zero power, I get 1. This would be true if I had like 3 to the zero power. I would still have 1. Alright, so now let's look at the laws of exponents that we know so far. Alright, the first law, we said that x to the y power times x to the z power equals x to the y plus z. For the second one, we talked about x to the y power over x to the z power equals x to the y minus z. Now, our third law that we're going to talk about is if all real numbers x, all real numbers y, but y needs to be an element of the set of integers. That means y needs to be an integer. Then x to the negative y equals 1 over x to the y. And this is true. So if that integer is a negative, then it is 1 over x to the y. Now let's try a few examples. Here's our first one. For this one, we have 18 to the power of negative 8. Well, if you remember our third law here, when you have a number to a negative exponent, you rewrite it as a fraction. So this is 18 to the negative 8. So I would rewrite this as 1 over 18 to the 8th power. Let's look at the next one. Write the expression without using a fraction bar. Well, this here is our fraction bar. If I want to write this without a fraction bar, I can do the reverse of what I did here. So, first of all, let's look at 63. I could take 63 and write it to the negative 1 power. Now let's look at another example. We're going to make this a little more complicated. So let's say I have two numbers to a negative power and I want to multiply them. Now in this situation, at no point are we going to evaluate our powers. We're going to simplify them. So for this situation, I have 12 to the negative 4 times 12 to the negative 7. Well, one way to look at this is I could say I have 12 to the negative 4 minus 7. Well, it's really important to remember to DPS this so that I realize I'm adding two negatives. And I would get 12 to the negative 11 power. But it says to use only positive exponents. So I would write this as 1 over 12 to the 11 power. Let's look at another way I could have solved this problem. These are both negative exponents, so I can rewrite them as 12 to the 4th power times 1 over 12 to the 7th power. Now I can solve it without worrying about the negative exponents. So I have 1 over 12 to the 4th plus the 7th, which gives me 1 over 12 to the 11th power. This says write an expression using only positive exponents. So if I have m to the 4th power times n to the 2nd power, I need to worry about this one because it's got a negative exponent. I'm going to leave m on top because it's to a positive power. And I'm going to move n to the bottom and convert its exponent to a positive. Now I've used only positive exponents, but I have the same expression. One's written with negative exponents and without a fraction bar, and one is written with a fraction bar and no negative exponents. So here's one that says write the expression without using the fraction bar. So I have 11 p to the second and q to the sixth. Now I want to convert this one so that I no longer have that fraction bar. So I can leave 11 p to the second because it's above the bar, but I have to convert this one. So I can change it to q to the negative 6 power. So this would be my solution. Here's one that says find the product. Our variables are to the negative power. Be careful though, because the 6 and the 14 are not to the negative power. So I have 14 times 6 on top, and then I'm going to move my variables to the bottom, m to the 4th power times m to the 9th power. Now this will be much easier to solve. 14 times 6 is 84. Then I have m to the 4th power plus 9. I can rewrite this as 84 over m to the 13th power. So when you come across problems like this, what's important to remember is that the power only applies to what it's attached to. In this situation, it's the variable. Here's another example. It says find the quotient, write your answer using only positive exponents. Well, it looks like part of our problem's disappeared here, so I'm going to rewrite it. 30n to the negative 15th power over 34n to the negative 16th power. Now don't let this confuse you. Negatives we're just going to switch. So I'm going to rewrite this as 30. To get rid of this negative 17 or 16, I'm going to move it to the top. So n to the 16th power. Now I don't have to write it as a negative power. On the bottom I have 34, and I'm going to take this negative power and switch it. This is another way of writing this using only positive exponents. Now, I'd like to simplify this as well, because my number part here could be simplified, okay, as well as this. So now I have n to the 16th over n to the 15th. To solve that, I would write n to the 16 minus 15. Here, I can divide both 30 and 34 by 2. And I'll get 2 goes into 30 15 times. 2 goes into 34 17 times. Now let's do the math with our exponents. So I have 15 over 17, and 16 minus 15 is 1, so to the first power. And I found the quotient, and I've written my answer using only positive exponents. So that was kind of a multi-step problem. Here's another one. In this situation, again, I want to take care of my negative exponents first. Remember that negative 10 only applies to k, not 19. So to rewrite this, I would have 19 over k to the 16 times k to the 10. So now I've switched it from dividing to multiplying. Alright, let's rewrite that again. 19 over k to the 16 plus 10, or 19 over k to the 26th. So that one was a little bit easier. Here's one more example. W to the 3rd power, y to the 13th power, over w to the 11th power, over y to the 6th power. Right? This is a division problem. So I'm going to separate my variables for now. This is like w to the 3rd minus 11, which gives me w to the negative 8th. That means my w is going to end up at the bottom, which makes sense because the larger number was at the bottom. So in the bottom of my fraction, I'm going to have w to the 8th. Now let's look at our y's. I have the problem y to the 13th power minus 6. Okay. For that, I would end up with y to the 7th. Notice it's positive, so I'm going to put my y to the 7 on top. And this would be my final solution. Another way to look at that problem is if I have w to the 3rd power over w to the 11th power and y to the 13 over y to the 6th, I can divide the top and bottom by the same thing that they have in common. So they have in common w to the 3rd, and they have in common y to the 6th. If I do the same thing to the top and the bottom, I'm dividing my fraction by 1, which shouldn't change its overall value. So dividing by y to the 3rd cancels out, or w to the 3rd cancels out w to the 3rd. Dividing these gives us y to the 7th. Here, this cancels out and leaves me with w to the 8th. And my y to the 6's cancel out, and I end up with the same solution. This is the end of the video on negative exponents. There are a few examples of problems for you to try.